They shimmer, they dance, and they seem like magic. But the northern lights are more than just a visual wonder. They're a powerful display of space, weather, and Earth's hidden defenses. Here's the fascinating science behind the Aurora Borealis. Hey there, welcome to my channel. First, let's get the obvious out of the way. What even is an aurora? In case you didn't know, the Aurora Borealis is our fancy name for the northern lights. But down south they have the same thing going on. It's called the Aurora Australis. For simplicity's sake, we'll just call them auroras. And auroras happen when the sun blasts so much energy towards the Earth that it hits our atmosphere and makes the gases glow. But it's not nearly that simple, so let's dig into the science. Ever wondered what the Aurora Borealis really is? It's a stunning light show in the sky caused by charged particles from the sun interacting with our atmosphere. When the sun sends out solar wind, a constant stream of charged particles, it sometimes launches these massive bursts called coronal mass ejections, or CMS. These bursts carry magnetic fields that can line up with Earth, directing particles right at us. Sometimes solar flares, huge explosions on the sun, also send high-energy radiation our way. When these charged particles hit our atmosphere, they energize gas molecules, which then release that energy as beautiful light. That's what creates those magical auroras we love to see. Pretty cool, right? No, too, it all starts with the sun. The sun is basically a giant nuclear fusion reactor. It's constantly generating energy and blasting it out into space in the form of solar wind. Most of the time, this solar wind is just made of protons and electrons, but sometimes it can carry heavier ions like oxygen and helium. These particles travel through space at incredible speeds, often over 100 kilometers per second. When a solar storm hits the Earth, most of the particles are funneled along the magnetic field lines and guided toward the North and South Pole. No, 3. Earth's magnetic field at work. The region around the Earth dominated by our magnetic field is called the Magnetosphere. You can think of it like an invisible shield protecting the Earth from the solar wind. Without this shield, all the charged particles would just slam into our atmosphere and cause all kinds of chaos. But instead, they're guided around the planet and focused at the North Pole and South Pole. Once they get there, they start interacting with the gases in the upper atmosphere. In the upper atmosphere, the gases are mostly oxygen and nitrogen, but there's also a bunch of other stuff like argon and carbon dioxide. These particles collide with the gas molecules and cause them to glow. No, 4. Why different colors? Auroras can be all kinds of different colors, from green to red to blue and purple. The colors depend on two things: the kind of gas that's being hit and how high up it is in the atmosphere. Lower down, around 100 kilometers above the ground, you'll mostly see green light. That's because oxygen molecules absorb energy and release it as red light. Higher up, above 200 kilometers, excited oxygen releases energy as red or even violet light. At even higher altitudes, the thin atmosphere can't even support these excited states, and they release their energy as ultraviolet light. Nitrogen in the atmosphere can also glow blue or purple. Basically, it depends on the atmospheric chemistry and the altitude. All these factors combine to make the stunning auroras that we see. No, 5. Where and when to see it. If you want to see the northern lights, you're gonna want to head far north. The best places to see them are Norway, Finland, Canada, Alaska, and Iceland. You'll also want to go during the winter months when the nights are long and dark. Your best bet is during a solar maximum cycle, which occurs about every 11 years when the sun is most active and the solar wind is strongest. You can check out websites that give space weather forecasts to help you plan your trip. Alright, here's a bonus fact for the end: auroras can mess with technology. During a solar storm, the glow in the sky can interfere with GPS and communication satellites. So if you're outside with an aurora and your phone starts acting weird, you'll know what to blame. Now you know why the sky glows. If you could see the northern lights from where you live, where would you go to see them? Let me know in the comments below, and don't forget to subscribe, like, and share this video if you enjoyed it. We've got lots of other videos about space and science right here. Thanks so much for watching. I'll see you next time.